Hello, Reeb. What's up? How are you?
What's up, everybody?
Why do I do this?
What's up, everybody?
Okay, we're live. Okay, seems to be working. And yeah, 2 likes. How many people watching? 3 people watching. Very low attendance, which is fine, I guess. Let's pause this. Very late. I also started very late. Just a quick question, Arif. Did you get a notification that we'll be going live? Hi, Akram. What's up? Oh, okay. Fair enough, Mason. Okay. ठीक है. Don't know why you're tired. Fair enough. All right. Okay. ठीक है. ठीक. Hey, you guys are too kind. 6 likes. Wow. 11 people watching. Big crowd. So we're doing something very, how should I say this? Brief. It's just a small part of electrolysis. We're going to wrap that up. And as the title says, we're going to talk about fuel cells, right? And yeah, essentially. Let me just give me a minute, organize myself better. I don't deserve the likes today because I feel I'm very underprepared. It's like a very hectic week this time around. Oh, that's interesting. What just happened? Okay. Chalo, I think we can start. I need to open the camera for the Zoom. I think we're in action. ठीक है, let's start. Okay now. So I'll try to make this more fun than it should be so you guys understand better, because we don't have to absorb a lot. End of the day, we can just like read a paragraph and just memorize some steps, and that's what most people do. So we'll try some extra bit and try to understand something. What's going on? Okay, what's gonna happen is you have a beaker and we'll try to put some. Before anything, can I just make this slightly larger? Okay. Okay, and what's a good color for magnesium? Let's go with gray. I have a magnesium bar in a solution. Coloring it. Then we have a copper bar in a solution. Right? And the solution has well, it's water. It's in water. Why did I not do that? Okay. And I call it a solution because it has some ions in it. So you put so something like sodium chloride in it, and then you're happy. So it's ions, right? It's an electrolyte. It can conduct electricity. It's a solution that can conduct electricity or has ions in it. ठीक है. Now at this point in time, what's happening is, now one thing is that, like when is AS organic chemistry? Hello Abdul Ghani, hello. AS organic chem, you have to subscribe to teaching circle for that. Anyway, I shouldn't do that. Hello Saad, welcome. Hello Rida, you guys are slightly late, but I was also late. Okay. ठीक है. So in chemistry, especially or in a lot of sciences, what happens is, in real life, many complicated things are happening to different things, but we don't explain it in a particular chapter. And chemistry, mein, that's an issue because I tell you something about a metal in the chapter metals, then we go to electrolysis and I talk about the same metals but like in a completely different way. And I think people get a bit confused with that. What do you guys think? Is that do you guys understand what I'm trying to say? Does that make sense? What happens is like I didn't know this could happen, and like you're not expecting metals to do this, and but they do such something so complicated. Massam agrees. 47 days mein you can do O-level chem, depends on your preparation and depends if you're studying with us. No, I'm just joking. I don't know, that's a complicated question and I don't want to answer that question, like it's just a weird question. It just won't lead to something good. I can give you false hope, maybe I can give you encouragement, or I can discourage you from studying, whatever my answer is. So the question is serves very little useful purpose. You just need to try your best. Saad, ठीक है? Need to do organic, then you're all right. Like this is both IGCSE and O-level chem. Okay, so you guys agree. So what I'm gonna say is what's happening right now on both is the copper is solid over here on the right hand side. Let's get a different color out. The copper is trying to turn into ions, right? Not too strongly, like very big, like barely, right? So it's trying to turn into ions, copper 2 plus ions, and give 2 electrons. And on the other side, magnesium is trying to do something similar. Magnesium is trying to turn into magnesium 2 plus ions. Magnesium 2 plus. And they're both forming 2 plus ions. It's just a coincidence. I just use those metals that turn into 2 plus ions. Take care. Yeah, energy from chemicals. Hello, Arisha. Welcome. It's been a while. Okay, but let's continue. Okay. Now, if you come back to this, it just stays as copper and it stays as magnesium. Why? Why? Why doesn't it all turn into ions? Well, as more and more electrons are being produced, यहाँ पे electrons भर जाते हैं, and the reaction stops because there are just too many electrons in this thing. And if you touch it, you don't feel anything because even a lot of electrons for it is not a lot of electrons actually. But this reaction kind of stops because there's no place for the electrons to go, right? And over here, there's no place for the electrons to go. They don't jump directly into the solution. The solution over here, I'll also highlight, electrolysis mein, we talk about the solution is also part of it. Right now what we're trying to discuss is focusing on these 2 electrodes, and we'll try our best to ignore the electrolyte or whatever it is in the solution. Our primary focus is whatever is going on technically outside of the solution, if that makes sense. It has been a long time. It feels like a really long time. But wasn't I with you last week? I think I was. Oh well. So the electrons don't have anywhere to go. So the reaction like 0. Millions of zeros, 1% hota hai, and it stops because there are just too many electrons, and nothing happens to the copper and nothing happens to the magnesium. And this is something like, and it's also a reversible reaction, by the way. So yeah, the copper ion can also turn back into copper. So, but you don't notice these things at all because have you ever seen this being discussed at any time before this? I didn't put electrons over here. Okay. What if you could take away the electrons, right? What if you could take away the electrons and like add a wire? Well, they would keep on reacting until all of it would turn into ions, or they'll be part of the solution. But the solution should be like a lot as well, because after a certain time, when the solution becomes technically saturated, it would stop as well. But it would happen a lot more. Okay, are you guys following so far? I think I'm talking a lot more than how important this sub-chapter is. Abdullah is following so far? Okay. So you can do many things, right? Okay. 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 You guys are following. You guys are smarter than me. Okay. What you do is you don't, link the wire and try to funnel out the electrons. What you do is you connect these two together. And just for the fun of it, you put a bulb in the center. You know where this is going now. ठीक है? Arisha's mocking me. Arisha, you mocking me? You mocking me? Okay. Yeah. Now what's gonna happen is electrons will flow from one of these metals to the other metal using this wire. Or the other way around. Where do you think they'll travel and why? It's been a long while since you heard. But technically you were mocking me. If mocking just means to copy someone. So you did mock me. Can I write a little bit as well? What do you want me to write? Okay, I'll try writing more. But my question is, I'll write more, I'm just joking right now. But my question is, where will the electrons and how will the electrons travel right now? Abdul Ghani, did you enjoy my class yesterday? What do you think of my students? I think they're little crackpots. I wanted to say crackheads, but I think it's a little unfair. Oh, you did? Oh, that's good. Aren't they just crazy? And I think a few showed up who were just not my students. No, my own class. My class had their mocks today for grade 10, and I did a last minute revision. That's one of the reasons why I couldn't take the class, because I hadn't done anything for them for the longest while. So I did a video, YouTube things for them, and yeah. Anyway, but no one's answering my question, or people don't know. I think. Do we not know how to guess what to do over here? Do we not know what to do over here? I don't know. Okay, fair enough. Okay, that's fine. Okay, so metals have a tendency to form ions, right? By यार मैं तो थोड़ा कुछ ज़्यादा ही crackpot चल रहा हूँ आज, I think. And to Arisha, what I'm saying in Urdu is, I am kind of acting like a crackpot today because I'm just looking at what I'm writing down and it's just weird. Tika, right? So metals have a tendency to form ions, essentially to react. The magnesium forming an ion is it reacting, right? And there's a scale of this tendency to form ions, or this tendency to react. Some metals react more than others, and others react lesser than other metals. Right? Now, Abdul Ghani got it, I think. Right? Now, between the two, looking at the reactivity series, magnesium is way ahead on the reactivity series. Magnesium is way ahead, like this is like the third guy, and copper is like the second last guy in the reactivity series, right? So which of these two has a higher tendency to form into ions, or a higher tendency to react? Magnesium. So between a competition, or between a tug of war, or between like which of these, and you've seen this, right? Like we use this everywhere. Magnesium will form ions rather than copper. So the electrons, there's more force. I'm using the force loosely. There's more incentive for electrons to form here and be pushed through this right? Let's have a good example for this. Yeah, like if you're trying to push a box and there's one person trying to push it like that, and there's another person trying to push it like that, the box will only move away from the stronger person because he's pushing it more. If this person is stronger than the other one, the box will move over there. Magnesium has a stronger tendency to produce ions than copper, so the electrons get pushed over here. And why are electrons being formed? Because when it reacts, there are more electrons here than on the other side. Does that make sense? Yeah, so magnesium forms electrons a lot more, and that's the way the cookie crumbles. And electrons travel from magnesium to copper. Travel of electrons. And if the electrons are moving, what is that called? What's the word you use for when you see electrons moving? What is the word we say for electrons that are moving? Any physics people in the room? Electricity. Okay. Okay. There's a more accurate word. Electricity is very close. You know, like, I mean, what's the other word for it? Current. Yeah. This is an electric current. Moving charges are an electric current. So if the electric current is going, what's going to happen to the bulb? What's the worst highlighter in history? Okay, I don't know. Right? It's going to light up. Right? This is an electric cell. This is a cell. This is the same battery you have on your phone. This is a cell. Right? Now we put a bulb over here, but you could put anything over here. You can literally put a phone to charge and it would charge depending on if the voltage is correct. And I mean, that's a good question. We'll just set it up. We're working on that's essentially why I'm so tired. We're working on that. You'll know shortly in a day or two. Take care, Amil. But essentially, you have to go to chemwithbilal.com and you'll have a sign up process there. With me so far? Let's spam the saluting emoji if you guys understand this. This is a simple cell. Okay, I think it was more or less straightforward. Okay. Now, what's different about this cell that I have made? It has 2 copper electrodes. I'm thinking that I really want to. Then again, I might just be dying. Let's just decide in a bit. What do you guys think? Mesam said he's busy, but you can always watch the recording. That's not, like, sure you won't be here, but what do you guys think? You want to, or we can have it on Monday? I'm kind of thinking I might just have work. But I do want to finish a lot. A what? A what? What are you asking? Up to me? That's very gracious. A class tomorrow. But I might have work, and I'll just disappoint you guys how I've been disappointing you guys for a few weeks. But hey, yeah, we try to make up for it. Yeah, ठीक है. I just felt very guilty for not taking yesterday's class. I was just, anyway. But yeah, my question is, what's gonna happen now? What's different over here is both copper are over here. ठीक है. Now, what's gonna happen right now? There was no class yesterday. I cancelled it. What's gonna happen right now? Now, these are literally the same people pushing. They're equal in strength. So will the box move anywhere? Will it go right or will it go left? Or will it move at all? Will it go right or will it go left? Will it move? Right? So the tendency, they'll both have the same amount of electrons being produced, the same tendency, the same reactivity. So these electrons are going to push from this side, these electrons are going to push from this side, and because the potential is the same, there will be no flow of charges either here or there. So what do you call electrons when they're not moving? Well, nothing, so there's no current going on, and this bulb will not light up. And does that make sense? How would you explain that? What would you say if I say, explain chemically why this is not lighting up? Not in terms of electrons, but just generally. What would you say? They have the same reactivity, so there will be no potential difference across the bulb. Do you guys know what potential difference means, by the way? Potential difference. It's the same as voltage. If you see current as the amount of water flowing, the flow rate, voltage can be seen as the pressure of that water that's flowing, right? So you could have a lot of water flowing with very little pressure, right? If the pipe is very thick, right? So a lot of water can come in, but there's no pressure. You can't shower with it or whatever because it doesn't come out like that, right? Or you could have very tiny pipe with a lot of pressure. So yeah, so voltage is the pressure, so to speak. So there's no potential difference means there's no pressure across this wire. So if there's no higher pressure to lower pressure, the water or the electrons do not move. So the potential difference, there's no potential difference. There's no difference of potential. It does not move. Think of it this way. If there's a potential difference in gravity, a ball will move down. If there's no potential difference, a ball will not move. Right? Kind of like that. Okay, I think we spent a lot of time talking about this. Let's write some chemical equations for this one. By the way, not that anyone asks this, because I explain this because you might read it in a book and you might just get confused. A cathode is strictly defined as an electrode where reduction is taking place. Okay. And anode would be the opposite, where oxidation is taking place. That's how you define them. So when we were doing electrolysis, it was always the negative electrode where reduction was taking place. But over here, it's different. It's different. So the positive electrode is actually this one, and the negative electrode is this one, right? And where is reduction being taken place? Is taking place. Reduction is, let's work it out. What's happening over here is magnesium is turning into magnesium 2 plus ion. So it's losing electrons, loss of, this is oxidation. And this is over here, then that means, because copper will be gaining, if there was copper 2 plus, it would be gaining electrons to form copper, and reduction would be taking place, right? Let me just write that down in an equation. What's happening? Copper 2 plus, if there was copper 2 plus, gains electrons to form copper. And this is gain of electrons, so hence reduction is taking place. This is where reduction is taking place. And over here, oxidation is taking place. And this is referred to as a cathode, because cathode is not defined by the charge, it's defined where reduction is taking place, and anode is defined as where oxidation is taking place. So this is called the anode. Does this make sense? So technically, every time you're looking at a cell, it's the reverse. That's what people are told. But the reason for that is cathode is the terminal where reduction is taking place. And wherever, you don't have to work it out, you can honestly, I honestly feel, you can remember it. In a battery, cathode is the positive one, and the anode is the negative one. And in electrolysis, the negative one is the cathode, where, whatever you guys prefer. Copper metal would deposit there, yeah. But we're not really going into the deposit because, I said the solution was NaCl. But whatever the solution is, whatever the positive ion is, that'll turn into this thing. And we're not looking into the details of it too much, right? Again, we're not caring too much about the solution. But if it was copper sulfate, definitely. But right now, I started with saying it's NaCl. But we're not caring, we just care this is an electrolyte. So we would have sodium ions turning into sodium metal by absorbing electrons. But again, we don't, I just gave this as an example to show, indeed, in fact, reduction was taking place. But we don't really, care, again. We just care about, so questions would be like, we'll see the questions and you'll see they won't talk about the solution part. They'll talk about voltages a lot. Okay, does this make sense? So far, aside from the thing I'm avoiding to answer, because we just don't care. Lol. Okay, let me see if I can open a question up. Okay, let's start with A5. I'll just give some room so you guys can do the other parts as well. Let's try this. I'll give you guys a head start. Meanwhile, why do I have another? Would the copper electrodes decrease? Habiba is asking, would the copper electrodes decrease in mass? Copper ions are also released? Well, the copper ions, they're not being released right now, but ideally that would be the case, especially in extraction of copper. If you remember a few videos ago, how we use metals, electrolysis to extract metals like aluminum and copper. We do see that essentially happening, and that would happen, Habiba. But यहाँ पे copper ions are not being produced. It's technically the opposite, but again, for this case, we're not too interested in what's going on there. We're trying to work out, other properties of the same chemical process that's going on, this same electrochemical process. Let me also open up my other worksheet. Oops, I went to a different page. That's not cool. But if you have a follow-up question, Habiba, please ask. Okay. The equation, how this is related to fuel cells? They're just asking, it's starting with the ionic thing, and then we're gonna go talk about just cells in general. Then we can talk about fuel cells after that. I still don't understand. Copper, they're more, Abdul Ghani, they're more ions. What's your question above? I'm trying to find it. Messam's question. We're going to go towards it. Screen is blurry. I'm checking YouTube and it looks fine. So just wait a minute, it'll come back. Mm-hmm. How long is the class? Till 6:50? Maybe even 7 o'clock? Okay, the ionic equation is, you have to also write, copper is also acting as an ion. It's only the sulfate over here that's not really doing anything. It starts off being SO42 minus, and after the reaction it's still SO42 minus. So it's one of your spectator ions. So if I write the equation down, you have zinc and copper 2 plus reacting to form zinc 2 plus and copper. Yeah. Yes, Abdulghani got it. My screen, okay. I was about to complain about the color, but I helped myself. Mohammad Alim, there will be an option announced on Chem with Bilal soon. So please follow the website and you'll get it by tonight or tomorrow. Just visit it tomorrow and you'll get detailed explanation on how to do it. Okay. Okay, sorry. The next part of the question, reaction can be used to generate electricity in a cell. Oh, it's a typo. Wow. Hey, we just found a typo. Draw an arrow on the diagram to show the direction of the flow of electrons in the wire. What do you guys think? You have zinc and you have copper. What do you guys think? Zinc 2 ठीक है. The voltage of the cell was measured when the following metals were used in electrode 2: copper, iron, lead, zinc. Complete the table by entering the metals in the correct order. What's our reactivity series? We have to use that a lot. Or can we just organize them as the most to least reactive? If one is the, what's a good color? If one is the most reactive and 4 is the least reactive, I'm pretty confident copper is over here, right? Now iron and zinc, lead and zinc, oh sorry, iron and zinc. Lead, I'm guessing it's number 3. I can't remember my reactivity series. Zinc, poso, camo, zittel. Zinc is number 1. And lead is after iron, I know that. So I'm guessing honestly. This is how the reactivity series is. This is the most reactive. Then iron, then lead, then copper. Shall I open the reactivity series? I'll have to. Electro. And we have this. Like that. And in fact, there's my zinc first, iron second, lead 3, and copper 4. And I think I'm right. ठीक है, I should remember these things. Zinc, Fe, okay. Abdul Ghani also said it. Zinc to, okay, Abdul Ghani also said it. ठीक है. Complete the table by entering the metals in the correct order. So what's happening is they're changing the metals. Are they? Yeah. So let's take a look. In this experiment, if I have copper over here compared to copper, right? What will be the voltage over here? What do you guys think? Remember we did this? Like 5 minutes, 10 minutes ago. The highest. The highest. Interesting. Why do you say that? Why do you say the lowest? Why do you guys say that? If this was copper over here with other copper, this is copper, right? If I put another copper over here, what would happen? People of the same strength pushing the box. Nothing. What is highlighting nothing is going on? Does that make sense? Does that make sense? And if I still compare it with copper, instead of copper, if I had, let's say, iron, what would be the voltage reading out of the 4 of them? .78. Why do you say though? Oh, 0.78. I think you're right. I was thinking that was the first one. I was thinking iron should have been here. Nope, you're right. You're absolutely right. iron would be 0.78. Do you guys follow? Masam, Ghani? Other people, do we follow? Yes? Okay. So everyone is more or less clear as to what's going on. Zinc, and what's the other one? Lead. Okay. Zinc, iron, lead, copper. And that's the order. Hi, Nim, how are you? Zoom in a little, I'm sorry. Does this make sense? What do you guys think? What do you guys think? Okay. Anyone confused? I think there might be a few confusions. But it's kind of very straightforward. The higher the difference in reactivities, the higher the voltage. Does that make sense? Crickets chirping in the background. Well, what do you guys ask now if you guys don't get it? What do you guys think? How many? Miral gets it. Rida, Arisha, right? I think the pressure example works the best. Should I explain this a bit more? Okay, Arisha gets it. Okay, I guess other people are slight AFK right now. No one's commenting or replying. Okay, when metal M was used as electrode 2, it produced a higher voltage than zinc. Suggest a name for metal M. What do you guys think? Why did I use two different colors? Because I felt like it. Trying to make it look pretty, but that didn't work. But part D, what aluminum? What's our reactivity series? Aluminum. Any of these metals are fine. It can't be carbon because they're asking for a metal. But any of these metals would give you the correct answer. Let's go with aluminum. Aluminium. Yeah. It is higher up in the reactive. Any of those metals are fine. I think aluminum is probably a better aluminum or magnesium, because if you throw any other thing else aside from aluminum, magnesium is kind of wonky as well. Aluminum is the best choice, even magnesium, because potassium, sodium, and calcium blow up everything when you put it in water, right? Vardhan, congratulations. Okay. Let's see if we have more questions. There is one more. But it's very similar. Yes. Yeah, but we're almost out of time and we didn't touch fuel cells. Not that... yeah. Yeah. Hang on, give me a second. I want to check if order of reactivity of some metal is shown below. Okay, let's try this question out. And any other question we can do real quick. Took a lot of time. Okay, let's try this question out. One more question, and no, two more questions. Complete the diagram below to show. You guys ponder on the second part, whereas I focus on the first part. Complete the diagram below to show how you could measure the voltage between the two different metal electrodes X and Y. How would you do that? Or you could have just drawn the symbol for a voltmeter. Take it. That's all you needed to do. Okay, the order of reactivity of some metals is shown below. Iron, the most reactive, cobalt, tin, copper, silver. Which combination of metals from this list would produce the highest voltage when used as electrodes in an electrochemical cell? Iron and silver? Absolutely. The weakest person and the strongest person, if they go into a tug of war, this guy is gonna obliterate the other guy, right? And that's the idea. So that's what you say. Iron and silver. Right? ठीक है. Silver and iron, yeah. ठीक है. Is that okay? We'll touch on fuel cells. I think let's not have a class tomorrow if that's okay. I'm just being lazy about it. I'm trying to sneak my way from missing a class tomorrow. I think I'll be very tired. I have a strong feeling. So let's continue this on Monday if it's okay with everyone. Sorry, Massam, I didn't get to talk about fuel cells up for a bit, but we'll talk about fuel cells Monday. Up to me. I feel guilty about it. Okay, let's do Monday. What else? Yeah, I guess that's it. I think Messam's upset because we didn't touch on fuel cells. Okay, is that clear? Any questions? Okay, it's all right. Okay. ठीक है. Live streams happen Mondays, Tuesdays, Thursdays, Fridays, Saturdays. Why not tomorrow? Because I was trying to do a makeup class, but it's Sunday for everyone. I think I didn't. I avoided yesterday's class because I was very tired. I couldn't take the class. No questions? Okay, ठीक है. Let's end it here. We won't do a class tomorrow because we generally don't have one. It was a makeup class, but I think I will be very tired tomorrow to take a class. So we'll do Monday and try to have, yeah? You still have bio class. Good luck. Where are you doing the bio thing? All right, guys. Thank you for coming. Thank you. Bye-bye. Take care. I hope you guys understood electrochemical cells. But yeah, all right. Bye-bye, guys. Bye-bye.